Welcome to ISPFL6 Object-Oriented Programming. Polymorphism, static binding and dynamic binding. It refers to the execution of a program where type of object is determined or known at compile time. That is, when compiler executes the code, it knows the type of object or class to which object belongs. While in case of dynamic binding, the type of object is determined at runtime. Static binding. When type of the object is determined at compile time by the compiler, it is known as static binding. If there is any private, final, or static method in a class, there is what we call a static binding. Dynamic binding. When type of the object is determined at runtime, it is known as dynamic binding. In the above example, object type cannot be determined by the compiler because the instance of dog is also an instance of animal. So compiler doesn't know its type, only its base type. So based on the code, the output is dog is eating. Method overloading. Method overloading is a feature that allows a class to have more than one method having the same name if their arguments list are different. It is similar to constructor overloading in Java that allows a class to have more than one constructor having different argument lists. Different ways to overload the method. First, we have the number of parameters. Second, we have the data type of parameters. And the third is the sequence of data type of parameters. Different number of parameters in argument list. This example shows how method overloading is done by having different number of parameters. In the above example, method disp is overloaded based on the number of parameters. We have two methods with the name disp, but the parameters they have are different. Both are having different number of parameters. Based on our code, our output will be A followed by A space 10. Difference in data types of parameters. In this example, the method disp is overloaded based on the data type of parameters. We have two methods with the name disp, one with parameter of car type and another method with the parameter of int type. So based on our code, our output is A then followed by 5. Sequence of data type of arguments. Here, method disp is overloaded based on sequence of data type of parameters. Both the methods have different sequence of data type in the argument list. First method is having argument list as car and integer, and the second is having an integer and a character. Since the sequence is different, the method can be overloaded without any issues. So based on the code, our output is first, I'm the first definition of method disp, followed by I'm the second definition of method disp. Polymorphism. With polymorphism, a message is sent to multiple class objects, and every object responds approximately according to the properties of the class. Polymorphism is the capability of a method to do different things based on the object that it is acting upon. In other words, polymorphism allows you to define one interface and have multiple implementations. Polymorphisms in Java with example. So polymorphism is one of the OOP's feature that allows us to perform a single action in different ways. For example, let's say we have a class animal that has a method sound. Since this is a generic class, so we can't give it an implementation like roar, meow, oink, etc. We had to give a generic message. Now let's say we too have subclasses of animal class. We have the horse and cat that extends animal class. We can provide the implementation to the same method like this. As you can see, that although we had the common action for all subclasses sound, but there were different ways to do the same action. This is a perfect example of polymorphism. It is a feature that allows us to perform a single action in different ways. It would not make any sense to just call the generic sound method, as each animal has a different sound. Thus, we can say that the action this method performs is based on the type of object. Methods in Java. A method is a block of code or collection of statements or a set of code grouped together to perform a certain task or operation. It is used to achieve the reusability of code. We write a method once and use it many times. We do not require to write code again and again. It also provides the easy modification and readability of code, just by adding or removing a chunk of code. The method is executed only when we call or invoke it. Method declaration. The method declaration provides information about method attributes such as visibility, return type, name, and arguments. It has 6 components that are known as method header. So these are the different method headers. First, we have the method signature. Every method has a method signature. It is a part of the method declaration. It includes the method name and parameter list. Second, we have the access specifier. Access specifier or modifier is the access type of the method. It specifies the visibility of the method. Java provides 4 types of access specifier. First, we have the public. The method is accessible by all classes when we use the public specifier in our application. Next, we have private. When we use a private access specifier, the method is accessible only in the classes in which it is defined. Next, we have protected. When we use protected access specifier, the method is accessible within the same package or subclasses in a different package. And last, we have the default. When we do not use any access specifier in the method declaration, Java uses default access specifier by default. It is visible only from the same package. Third, we have the return type. Return type is a data type that the method returns. It may have a primitive data type, object, collection, void, etc. If the method does not return anything, we use the void keyword. Fourth, we have the method name. It is a unique name that is used to define the name of a method. It must be corresponding to the functionality of the method. Suppose if we are creating a method for subtraction of 2 numbers, the method name must be subtraction. A method is invoked by its name. Fifth, we have the parameter list. It is the list of parameters separated by a comma and enclosed in the pair of parentheses. It contains the data type and variable name. If the method has no parameter, left the parentheses blank. Then last, we have the method body. It is a part of the method declaration. It contains all the actions to be performed. It is enclosed within the pair of curly braces. Types of method. We have the predefined method and the user-defined method. Predefined method is also known as the standard library method or built-in method. We can directly use these methods just by calling them in the program at any point. Some predefined methods are length, equals, compare to, square root, etc. When we call any of the predefined methods in our program, a series of codes related to the corresponding method runs in the background that is already stored in the library. Each and every predefined method is defined inside a class, such as print open and close parenthesis method is defined in the Java IO print stream class. It prints the statement that we write inside the method. For example, print Java. It prints the word Java on the console. User-defined methods are modified according to the requirement or need of the programmer. Object class in Java. The object class is beneficial if you want to refer any object whose type you don't know. Notice that parent class reference variable can refer the child class object known as appcasting. Class in Java. A class can be considered as a blueprint using which you can create as many objects as you like. For example, here we have a class website that has two data members. It is also known as fields, instance variables, and object states. This is just a blueprint. It does not represent any website. However, using this, we can create website objects or instances that represents the website. A class in Java can contain fields, methods, constructors, blocks, and nested class and interface. A class is a group of objects which have common properties. It is a template or blueprint from which objects are created. So it is also logical in terms of entity, and it can't be physical. Encapsulation. So encapsulation in Java is a process of wrapping code and data together into a single unit. The whole idea behind encapsulation is to hide the implementation details from users. If a data member is private, it means it can only be accessed within the same class. No outside class can access private data member or variable of other classes. The advantages of encapsulations are: it improves maintainability and flexibility and reusability. The fields can be made read-only if we don't define setter methods in the class, or write-only if we don't define the getter methods in the class. User would not know what is going on behind the scene.